And for our last in this section, we're looking at lesson 5.4 today, the equations and graphs of trigonometric functions. So if we had the question, determine the solutions for the trig equation 2 cos squared x minus 1 equals 0, we saw in the last chapter we can solve this algebraically. And it would involve bringing the negative 1 over to the right. We'd be then dividing both sides by 2. We then square root both sides. Because, of course, as I said, cos squared x simply means that we take the x, we cos it, and then we square it. If we put the square root beside the x, we'd be under the impression we square the x and then cos it. So cos squared x means take the cos of x and square it. So we have to square root both sides, and we should get the positive and negative square root of 1/2. And when we rationalize the denominator, we could get the equivalent plus or minus root 2 over 2. So now that we know that cos x is either positive or negative 1 over root 2, we look at each option separately. We know that cos will be positive in the first and fourth quadrant. Our reference angle here will be 45 degrees, which means fourth quadrant will be negative 45 degrees or 315. With a reference angle of 45, then cos x will be negative in second and third quadrant. It'll be negative when we have an x of 135 or 225. So we could write a general form solution as a 45-degree angle plus or minus 90 degrees n, where n is the natural number. Graphically, we can take this equation, and we put it into our graphing calculator, and we then solve for the roots of this equation. We solve for the zeros of this equation. And we quite clearly see that the zeros occur, no big surprise, at the following points, exactly halfway between 0 and a half pi, which would be at pi over 4. And we can see we also have one at 3 pi over 4. We see we have one at 5 pi over 4. And we see we have one at 7 pi over 4. So we see in example 2 we have something a little bit more complicated. 16 equals 6 cos pi over 6. That should say x plus 14. And we then, in our initial attack, we bring the 14 over to the left-hand side, divide both sides by 6, and we get 1/3 equals cos pi over 6 x. We kind of stop and think at this point. We know that the cos is going to be positive in quadrants 1 and 4. So clearly the pi over 6x most likely represents an angle in quadrant 1. So then if we're looking at the version in quadrant 4, we're looking at 2 pi minus that amount. So that's why we see here that we have our original equation to represent quadrant 1, and we have our new equation to represent quadrant 4. As we continue along, we take the inverse cos of both sides to get rid of the cos on the right-hand side. We then can multiply by 6 over pi to get the x by itself, and we get 2.3509. And on the right-hand side, we know that the cos of minus 1 is, to the minus 1 of 1/3 is 1.2309. We subtract 2 pi from that, we divide both sides by negative pi over 6, and we get an x of 9.2572. We also know that we would have a period normally of 2 pi over our b value. In this case, we have a b value of pi over 6. And when we divide that, we get 12 as the period. So instead of 360 degrees or 2 pi, we'll be adding on 12n, where n is an integer, at the end for a general solution. So we can relate that algebraic solution to a graphical one. If we bring the 16 over to the left-hand side, we get 6 cos pi over 6x minus 2 equals 0. So if we program to our graphing calculator, y equals 6 cos pi over 6x minus 2, we can then try to solve for where the value of the function is 0. And it's clearly there at the zeros of the function. And those zeros are at 2.35. Our y value will be 0 there. And our y value will also be 0 at 9.65, roughly. And we do have a second option. We can take the graph of y equals 16 And we can take the graph of 6 cos pi over 6x plus 14. And when we graph them on the same axis, we see that what we're looking for here is the intersection of the two. We want to see where this function is worth 16. And it happens at this point here, and at this point here. At this point we have an x value, no surprise, of 2.35 and a y value of 16. And here we have an x value of 9.65 and a y value of 16. And of course, no lesson would be complete without the obligatory word problem. Here we have a sine function modeling voltage over time. And one of the interesting things here is we can look at the period. The period would be 2 pi over 120 pi. That very simply reduces to 1/60th. And we do have a word for that in Canada. It's called a hertz. And we're looking at the graphing the voltage function. It's going to look like that. We have the period here, 1/60th, being roughly 0.016, which makes sense, about 2/3 of the way between 0.01 and 0.02. And we see we end up having a maximum size of 170 to a minimum of negative 170. So although we could do an algebraic solution for the next question and replace 110 volts for voltage and then solve for t, I would prefer a graphical solution here. On your graphing calculator, you're going to need to use the last graph and also graph y equals 110 volts and then just see where the two intersect for the first time. If you are fortunate, the answer should be 0.002. Please feel free to pause and confirm that fact. And continuing in that kind of theme, the example on page 272 goes through the steps about how to come up with the function h of t equals negative 8.245 cos of 2 pi over 365 t plus 10 plus 12.585. But the most important part, or the most interesting part, is once you get to that point, it'd be very useful to be able to figure out an h of t value once you know t. And using the value feature on your calculator, you can actually type in, if you type in this function as a definition, you then type in h of 74 for the first question, and it will give you a complete answer right away. Go ahead and pause and see what answer you get, and then compare with mine. And if you're successful, you got 11.5587. If not, I guess you should try again. Or you can go through the fun of putting 74 into our function. And we get 74 plus 10 is 84. 84 divided by 365 times 2 pi, take the cos, multiply by negative 8.245, and then add 12.585. And you should get, again, that number. And just one last time, go ahead and try the work on this one, either by substitution into the equation or by attempting to use the values feature of your calculator. And you should get the following answers. You should get 20.4154 and 4.65076. Any questions, of course, you know where to reach me. And our last step for today is page 275, numbers 4, 5, and 8 to 10. Best of luck.